once again, so I welcome you into this channel. My name still remains Master Alfred Opio. I teach chemistry and biology. Now, last time we have looked at valencies of radicals and of elements. Today we want to look at the chemical formulae. In plural we call it formulae, but in singular we call it formula. So, chemical formula by definition is a representation showing the proportions of elements present in a chemical compound using symbols. So we look at how we can show the proportions of elements present in a chemical compound when we are using their symbols which have been given. So the concept under this one here is that what you should know under this chemical formula is you should try to recall what we learned the other day about valencies. So here you should know the valencies of elements, and also you should know the valency of the radicals. Now when you have known that, you should know how to write the symbols. You should know how to write the symbols of elements as well as the symbols of radicals. Now when you have known that, it will help us now to write the chemical formula of that particular compound. For example, if we have sodium chloride comes as a result of a combination between sodium and chlorine. When sodium have combined with chlorine, it gives us what we are calling the sodium chloride. So in this case, I said you should know how to write the symbol. For example, the symbol of sodium, last time we found it to be capital N, small a. That is the chemical symbol or the formula of sodium. Then for chlorine is capital C, small l. That is 1. 2, you should know also the valence of the elements. For example, the valence of sodium is 1. The valence of chlorine is 1. So, when they are combining together, the chlorine will give its 1 to sodium. Meanwhile, sodium will also give its 1 to chlorine, such that when they do combine, they will give us sodium chloride. But 1 is always silent. We don't write 1. Therefore, we shall say NaCl. This is what we are calling sodium chloride. This is what we are calling sodium chloride. That is example 1. I want to give you another example which is very interesting. For example, if we want to write sulfuric acid, this is a compound, by the way. Sulfuric acid is a compound. Sulfuric acid came as a result of combination between hydrogen and sulfate. This time here, sulfate is a radical. Remember we talked about radical, and you should know the valency of the radical. Now, here sulfate is the radical, then we have hydrogen. So, symbol of hydrogen is H. Then for sulfate is SO4. Now, what's the valence of sulfate? The valence of sulfate is 2. What about hydrogen? Hydrogen is 1. So we say when they do combine, the sulfate will give its 2 to hydrogen. Meanwhile, hydrogen will give its 1 to to sulfate. Are we seeing how it has come? That means if we want to write the formula of the radical, when the compounds consist of the radical like this one here, you need to put it in bracket. Put that radical in bracket. For example, we will say H2, then we put a bracket, place that radical inside the bracket. Then now we write 1. But now, 1 is always silent. But because now 1 is silent, when you don't write 1, it will not affect this. The purpose of putting it in brackets is that if here, for example, if here was 2, then you don't put a bracket, this 2 will affect this, and your thing will not be correct. But now, remember ours was 1, so this is 1. So 1 cannot affect this, even if you don't put it in bracket, such that the formula will be H2SO4. This is sulfuric acid. Lastly, I want to give you an example where here can either be a number that can affect this, so that you can put it in bracket. We shall call that one example 3. For example, if we have like zinc sulfate, sulfate. If you have like zinc sulfate, so with zinc sulfate, zinc is zinc combining with the sulfate. You have zinc combining with the sulfate. And the formula of zinc is capital Z, small n. Then sulfate is radical, which is SO4. Now in this particular case, remember I told you that I want to give you an example where there is a value that will tend to affect this one here. Value that will tend to affect this one here. So let me put the one which can affect. Let me say aluminium sulfate, so that here we shall have aluminium, where aluminium is written as capital L, small l. We know the values of aluminium is, what is the values of aluminium? The values of aluminium is 3. What about the values of sulfate? The values of sulfate is 2. So the 2 come to aluminium and the 3 moves to sulfate. That's the way I've told you. This 3 will have to affect this one here if you don't put it in bracket. Therefore, we say Al2SO4, and you put it in brackets. Then now you put your 3. This is what we call it aluminium sulfate. Remember, if you did not put it in bracket, this 3 will have to affect that. So, if you're consisting of, if your compound consists of radical, you put that radical in bracket. If the figure this side here is now more than 1. Now, as I conclude, this value that we write down here, they represent the number of atoms of that particular element. Like here, it means we have 2 atoms of aluminium. 2 atoms of aluminium. Maybe if you have a figure which is written in front of a compound, for example, if you have here 2, we call that one molecules. So we call this one here 2 molecules of this compound. If you have a 3, we call it 3 molecules of this compound. Like 3 molecules of aluminium sulfate, 4 molecules of aluminium sulfate. So this one here always comes as a result of balancing equation. If now you have balanced your equation, that's when it comes like this. Next time we shall look at how to balance a particular equation. Otherwise, that is how we can write the chemical formula of any compound that you may get. Thank you so much. I wish you the very best of the day. Remember to like, subscribe, and share with your friends.